Viewers, in today's class we are going to solve some important problems from indefinite integrals. So let us first take this integral. We have to evaluate cos 2x plus 2 sine square x divided by cos square x. So let us call this integral as I. Right now, here uh, for sine square x, let us substitute uh, 1 minus cos square x. So this integral becomes, for cos 2x we can substitute 2 cos square x minus 1. So here we'll make use of these two trigonometric relations, that is sin square x is equal to 1 minus cos square x and cos 2x is equal to 2 cos square x minus 1. So let us substitute these values here. So we get 2 cos square x minus 1 plus 2 times 1 minus cos square x divided by cos square x. Right? So now we simplify the numerator. So we get 2 cos square x minus 1 plus 2 times 1 2 and minus 2 cos square x divided by cos square x. Now the numerator becomes, see here we have 2 cos square x, 2 cos square x, so this term and this term get cancelled, so we are left with 2 minus 1 is 1 divided by cos square x dx, right? And this is equal to sec square x, and we know that the integral of sec square x is tan x, and here we'll write the constant of integration as c. Let us evaluate this integral. So here we'll make use of two results. The first one is log m raised to n is equal to n log m, and other one is e raised to log of say f is equal to f, right? So this integral I can now be written as e raised to log x raised to 6, because this 6 can be written as a power of x, and similarly here we have e raised to log x raised to 5 divided by e raised to log x raised to 4 minus e raised to log x raised to 3, right? Now here we have used this result, and now this is e raised to log f. So e raised to log f can be written as simply f. So now we can write this as x raised to 6 minus x raised to 5 divided by x raised to 4 minus x raised to 3. Clear? Okay. Now if we take x raised to 5 common from the numerator, then we have x raised to 5 times x minus 1, and here we can take x cube common, and we have here x minus 1, right? So x minus 1 and x minus 1 get cancelled, and here we have x cube, this get cancelled, and here we have x square. So this is equal to x square dx, right? Now the integral of x square is x cube divided by 3, and we'll add the constant of integration, that is c. Clear? So here we have used the result x raised to n. The integral of x raised to n is x raised to n plus 1 divided by n plus 1, where n is not equal to minus 1. Clear? Now let us take this problem. So here we have to integrate this function cos 2x minus cos 2 alpha divided by cos x minus cos alpha. So let us denote this integral by I, and now here again we'll use the trigonometric identity, that is cos 2 theta is equal to 2 cos square theta minus 1. So cos 2x it becomes 2 cos square x minus 1, and cos 2 alpha becomes 2 cos square alpha minus 1, right, and divided by cos x minus cos alpha. Now the numerator can be simplified as 2 cos square x minus 1, and we have minus 2 cos square alpha plus 1, right, and divided by cos x minus cos alpha. Now this 1 and this minus 1 get cancelled, and we are left with 2 cos square x minus 2 cos square alpha, and taking 2 common we have 2 times cos square x minus cos square alpha divided by cos x minus cos alpha, right. Now this form is a square minus b square, so we can write it as a minus b, a plus b. So now this can be written as 2 times cos x minus cos alpha and cos x plus cos alpha divided by cos x minus cos alpha. Now the factor, these two factors get cancelled, and taking this 2 from this integral sign, so we have 2 times cos x plus cos alpha, right. Now see, here we can write these two as separate integrals, so we have 2 times integral of cos x dx plus 2 times integral of cos alpha dx, right. Now here the integral of cos x is sin x, so we have 2 sin x, and here cos alpha is a constant, so we can take cos alpha outside this integral sign, so we have integral of 1 dx, right. So this is 2 sin alpha sin x plus 2 cos alpha, and integral of 1 is x, and then we'll have the constant of integration as c. So finally we can write it as 2 sin x plus 2x cos alpha plus c. So this is the required integral of this function. Now let us take this problem. So here we have to integrate this function x cubed divided by x raised to 4 plus 3x square plus 2. So here we'll make use of the substitution method, and here we'll substitute x square is equal to t, right. So if we put x square is equal to t, then we get 2x dx is equal to dt, right, because here we'll have dt over dx is equal to 2x, so dt is equal to 2x dx, right. So now this integral can now be written in terms of t as here for x cube we can write x times x square, or we can write x square times x dx, right, and x raised to 4 can be written as x square plus 3x square plus 2, and from here x dx can be written as dt over 2. Now for x dx we can substitute dt over 2, and for x square we have t, so we have here dt over 2, and for x square we have t, so this is t square plus 3t plus 2, right? And this can be now written as half t dt divided by t square plus 3t plus 2, right? Now we can factorize t square plus 3t plus 2 as we can write t square plus 2t plus t by splitting the middle term plus 2, so this can be written as t times t plus 2 plus 1 t plus 2, so we can write t plus 1 t plus 2, right? So this denominator, the quadratic denominator, can now be written as half t dt divided by t plus 2 times t plus 1, right? Now here we shall make use of the concept of partial fractions, so we can write t over t plus 2 times t plus 1 as a divided by t plus 2 plus b divided by t plus 1, because both are linear factors, right? So now this can be written as a times t plus 1 plus b times t plus 2 divided by t plus 2 t plus 1. Now we can equate t to this term, that is a times t plus 1 plus b times t plus 2, right? Now we have to calculate the values of a and b, and for evaluating the values of a and b, we can substitute here t is equal to minus 1. So when t is minus 1, this term get 0, it becomes 0, and here we have minus 1 is equal to 0 plus b times minus 1 plus 2, that is minus 1 is equal to b, so b is equal to minus 1, right? Similarly, for getting the value of a, we can put t is equal to minus 2, so we get here 2, sorry, it is minus 2, and here we have a times minus 2 plus 1, and here minus 2 plus 2 becomes 0, so this term is 0. So minus 2 is equal to a times minus 1, so this implies a is equal to 2, right? So we have resolved this rational function into partial fractions, and a is the value of a is 2 and the value of b is minus 1. So this integral now becomes half, and for t divided by t plus 2 times t plus 1, we have a divided by t plus 2 plus b divided by t plus 1 dt, right? So now this is half, and for a we have 2 divided by t plus 2, and here we have minus 1 divided by t plus 1, right? Now this integral can be written as half, and this is 2 times dt over t plus 2, and this becomes half, and here we have minus 1 integral of 1 over t plus 1, right? So this 2 and this 2 get cancelled, so we have integral of 1 over t plus 2, that is log t plus 2, right? Because the integral of dx over x plus a is always log of x plus a, right? And here we have minus half, and integral of this t plus 1 is log of t plus 1, and here we have the constant of integration as c. Now substituting the value of t as x square, so we have here log of x square plus 2 and minus half and log x square plus 1 plus c. So this is the required integral of this function. We can also express this result as log this is x square plus 2, and this minus half can be written as the power of x square plus 1, so we can write x square plus 1 raised to minus half, right? So plus c. So this can be written as log x square plus 2, and we can write log of 1 over square root of x square plus 1 plus c. Now using the property of log, again we know that log m plus log n can be written as log of the product of m and n. So here we can write a log of this is m and this is n, so we can write log x square plus 2 divided by square root of x square plus 1 plus c. So this is the other form of the integral of this function. Now let us take this problem. Here we have to integrate sine x minus a divided by sine x plus a. So let us denote this integral by I. Now here again we'll make use of the substitution method, and we'll put x plus a is equal to say t, right? So dt over dx is obviously equal to 1, because the derivative of x with respect to x is 1 and a is a constant, so the derivative is 0. So here we have dt is equal to dx. Now this integral becomes sine, for x we can write t minus a. From here we can write x is equal to t minus a. So here we have t minus a, then we have minus a, and for the denominator we have sine x plus a is equal to t, right? And here we have for dx we can write dt. So now we have sine t minus 2a divided by sine t. Now here we'll apply the famous formula, that is sine a minus b is equal to sine a cos b minus cos a sine b, right? So if we apply this rule to sine t minus 2a, we get sine t cos 2a minus cos t and sine 2a, right, divided by sine t, and here we have dt. Now we can break this expression from here, and we can write this integral as sine t cos 2a divided by sine t minus cos t sine 2a divided by sine t, and here we have dt, right? Now sine t and sine t get cancelled, so we have here cos 2a minus cos t divided by sin t becomes cot t, and here we have sin 2a, right? Now we can separate this expression in terms of two integrals. So we can write integral cos 2a dt minus integral cot t times sine 2a dt, right? Now cos 2a is a constant, so we can write cos 2a out of this integral sign, and we have integral of 1 dt minus, here we have sine 2a as a constant, so we can write it outside the integral sign. So we have sine 2a, and here we have integral of cot t dt. Now the integral of 1 dt is t, so we have cos 2a t minus sine 2a, and the integral of cot t, the integral of cot x is equal to log of sine x, right? So here we have a log of sine t, and here we have the constant of integration as c. So we can write t cos 2a minus sine 2a log sine t plus c. And now resubstituting the value of t as x plus a, we can write it as x plus a cos 2a minus sine 2a log of sine x plus a plus c, and this can be written as x cos 2a plus a cos 2a minus sine it is sine 2a times log sine x plus a plus c, right? Now a cos 2a and c both are constants, so we can replace c plus a cos 2a by some other constant, say c1. So the integral of this function can now be written as x cos 2a plus minus sine 2a log sine x plus a plus c1, right? So here we can also use the modulus sign. So this log sine x plus a can be written as log of mod of sine x plus a. So we can also write here the mod sign. Here also we can write the mod sign, and here also we can write the mod sign, right? Now let us take one more problem. So here we have to integrate sin x plus cos x divided by square root of 1 plus sin 2x. So now here again we'll make use of the trigonometric identities. So here we'll use sin square x plus cos square x is equal to 1, right? And sin 2x can be written as 2 sin x cos x, right? So for this one we can write sin square x plus cos square x, and for sin 2x we can write 2 sin x cos x. So therefore this term, that is square root of 1 plus sin 2x, it becomes square root of sin square x plus cos square x plus 2 sin x cos x. Now this can be written as, this is a square plus b square plus 2ab, right? This is a square plus b square plus 2ab. So we can write it as a plus b whole square. So this can be written as square root of sine x plus cos x whole square. So now this is the square root sign, so we have sine x plus cos x square raised to half. So this 2 and 2 get cancelled, so we are left with sine x plus cos x. So this term, that is square root of 1 plus sine 2x, is now equal to sine x plus cos x, and this integral now becomes sine x plus cos x divided by sine x plus cos x. Now we see that the numerator and denominator are equal, so this term and this term get cancelled, so we are left with 1 dx, and the integral of this 1 is simply x, and here we have the constant of integration as c, right? Now let us solve this problem. So here we have to integrate 1 plus cos x divided by x plus sine x. So here I will make use of the substitution method. So let us substitute t is equal to x plus sine x, right? So dt over dx is equal to the derivative of x is 1 and the derivative of sine x is cos x, right? So dt can be written as 1 plus cos x dx, right? Now see, here we have 1 plus cos x dx, so for this we can write dt, and for x plus sine x we can write t, right? So we have dt over t. So the integral of 1 over t is log t, and we have plus c, that is the constant of integration. So again, resubstituting the value of t as x plus sine x, we can write log of x plus sine x plus c. So this is the required integral of this function. Now let us solve this integral. So here we have to integrate e raised to 2x minus e raised to minus 2x divided by e raised to 2x plus e raised to minus 2x. So here also we'll make use of the substitution method, and let us substitute t is equal to e raised to 2x plus e raised to minus 2x. So now dt over dx is equal to the derivative of e raised to 2x is 2 e raised to 2x, and the derivative of e raised to minus 2x is minus 2 e raised to minus 2x. So we can write 2 taking 2 common, so we have e raised to 2x minus e raised to minus 2x, right? So now dt divided by 2 is equal to e raised to 2x minus e raised to minus 2x dx. So for this term we can write dt over 2. So I can be written as dt over 2, and for this term we can write t. So here we have t. So taking this 2 out of this integral, so we have half integral of dt over t, and we know that integral 1 over x dx is always log of x. So here we have half log of t, and we have the constant of integration. So again, resubstituting the value of t as e raised to 2x plus e raised to minus 2x, so we have half log e raised to 2x plus e raised to minus 2x plus c. So this is the required integral of this function, right? Now let us solve this problem. So here we have to integrate x cube minus x square plus x minus 1 divided by x minus 1. So here we'll use the method of regrouping the terms. So here we'll regroup the terms and we'll write as, or we can take the common factors, right? So here we'll take x square, right? X square common from these two terms. So we have x square, then we have x minus 1, and here we have x minus 1. So we have x minus 1, and here we can write 1, and divided by x minus 1. So now by taking common, we see that this factor x minus 1 is now common, or it can be taken common out of this term and this term. So we can write x minus 1, and we have x square plus 1 divided by x minus 1. Now see, this x minus 1 and this x minus 1 get cancelled, so we are left with integral of x square plus 1. Now the integral of x square is x cube divided by 3, and the integral of 1 is simply x, and we have the constant of integration as c. So this is the required result. Let us take this problem. So here we have to integrate 1 over x raised to 5 plus 3. So now for to integrate this function, let us multiply the numerator and the denominator by x raised to 4, right? So we'll multiply the numerator and the denominator by x raised to 4. So this integral I, it becomes x raised to 4 dx, and x raised to 4 times x is x raised to 5, and here we have x raised to 5 plus 3, right? Now we'll make use of the substitution method, and let us substitute t is equal to x raised to 5. So dt over dx becomes 5x raised to 4. Now we can write dt over 5 is equal to x raised to 4 dx. Now for x raised to 4 dx, we can substitute dt over 5. So this integral now becomes dt over 5 divided by t, because x raised to 5 is t, and here also we have t plus 3, right? Now we can write it as 1 over 5 dt over t times t plus 3, right? Now here we'll make use of the method of partial fractions, and we can write 1 over t times t plus 3 as a over t plus b over t plus 3, right? So we have resolved this rational function into these two partial fractions. So this can now be written as a times t plus 3 plus b times t divided by t plus 3, right? Now we can equate 1 is equal to a times t plus 3 plus bt, right? Now we have to find the values of a and b. So the quick method is we'll substitute t is equal to minus 3 here. So we get 1 is equal to this term becomes 0, and here we have b times minus 3. So we have 1 is equal to minus 3b. So b is minus 1 over 3, right? Now to get the value of a, let us substitute t is equal to 0. So this expression becomes 1 is equal to a times 0 plus 3 plus this term becomes 0, and we have 1 is equal to 3a. So a is equal to 1 over 3, right? So we have obtained the values of a and b. So now this integral can be written as I is equal to 1 over 5 integral, and 1 over t times t plus 3 can be written as a over t plus b over t plus 3 and dt, right? Okay, so now we substitute the values of a and b. For a we have 1 over 3, and for b we have minus 1 over 3 and t plus 3, right? Okay, so now we can write 1 over 5 and 1 over 3. It gets out of this integral sign, so we have 1 over 3 integral 1 over t minus 1 over t plus 3, right, and dt. So this becomes 1 over 15, and the integral of 1 over t is log t, and the integral of 1 over t plus 3 is log of t plus 3, right? So here we can write the modulus sign, and then we have the constant of integration, right? Okay, so now we can resubstitute the values of this t here. So the integral I, it becomes 1 over 15, and we have log of t, that is x raised to 5 minus log x raised to 5 plus 3, right, plus c. And now using the property of log, that is log m plus log log m minus log n, can be written as log m over n. So we can write I as 1 over 15, and this can be written as 1 over 15 log x raised to 5 divided by x raised to 5 plus 3 plus c. So this is the required result.